Hello, and welcome to my presentation on the insecticide Imidacloprid, the effects on North American pollinators. Pollinators in America, there's over 4,000 types of bees, are estimated to add $18 billion to the value of all U.S. crops that need pollination every year. The general health of North American pollinators has been going down, though, through the years for various reasons. The insecticide Imidacloprid is slowly taken up by plants, and that makes its way up into the flowering parts of the plant, and that's where pollinators get exposed to it. It's used in all facets of society, in agriculture, even our own homes, and on our animals, and even our grass, and it's used in our gardening products that we use. Imidacloprid has been outlawed in Europe and severely restricted in 2018 by the US EPA. My data came from a USDA study on native bees. Over a year, at about 42 different days, specimens were captured. Some specimens were exposed to either 5, 20, or 100 parts per billion of imidacloprid, and others were not. These bees then were studied to see, for instance, how many days they were active, that their days lived, the days that they were paralyzed, if they were exposed to imidacloprid, and of course the percent days paralyzed, to the set that was not exposed to imidacloprid. My first question is there a connection between the imidacloprid concentration in parts per billion and the longevity of the bee, days lived versus days paralyzed? If you look at the current scatter plot graph, the red dots, which represent 100 parts per billion exposed, forms a very nice right triangle here, up to about 15 days paralyzed and out to about 15 days lived. As you can see, most, if not all, of the red dots at the 100 parts per billion concentration all expired and were paralyzed in that time period. Likewise, if you look at the blue, orange, and green dots, which were 25 and 0 parts per billion exposed, the days lived obviously are much longer, and the days paralyzed a little higher, but again, they did live longer, of course, to lower concentrations of being exposed to imidacloprid. My second look at the data for question one was a distribution of the days lived and the days paralyzed. After looking at the scatter plot, you would think that the distribution follows the same numbers, which it does for days lived and days paralyzed. For the days lived, you can see we had a 15-day period on both days lived and days paralyzed. So if you look at the days lived, most of the distribution falls within that 15-day period. Likewise, if you look at the days paralyzed, most of the distribution of their data falls within, again, the 15-day period. So the distribution graphs only backed up the scatter plot graph and what we seen in it. Question two in my study was, does the habitat floral host have a relation to the imidacloprid concentration in parts per billion and the Julian date the bee was captured? First, I did a scatter plot graph because I wanted to see if the floral host was seasonal, and as you can see by the different colored dots, it was, with the vaccinium being earlier in the year and versus the sunflower being later in the year, and the hive floral host being obviously at the end of the year. They were distributed across the dosages of 100, 20, and 5 parts per billion. And as you can see, I also have the dates that the bee are captured. So there is an even distribution. And like I said, there are there is seasonality to the floral hosts of the specimens taken. The previous scatter graph didn't give us a clear indication of the distribution of the data as far as the date, the count of the specimens, and the dosage of imidacloprid. This graph definitely shows you that there's two basic seasons in the specimen collection. The first one being here, where you can see up here at the beginning of this bee collection season, the dosages of 100% or 100 parts per billion, excuse me, were definitely at the beginning of that specimen collection. And as you can see through time and the dates, the dosages of 100 parts per billion go down. Likewise, during the kind of second seasonal, if you will, specimen collection, the dosages of 100 parts per billion again happened at the beginning of the collection cycle, and then as you can see in subsequent, the 100 parts per billion exposures did go down, and this is probably obviously due to the life cycle of the bees during that time, during the pollen collection time period. Since the scatter graph and the distribution graph for question 2 didn't quite give me any indications of whether the floral host has a relation to the imidacloprid concentration in parts per billion that were given to the bees and the Julian date the bee was captured, I went ahead and did a correlation of the data. And as you can tell, looking at the amounts of the first column here, the concentration, and then comparing it to the date the bee was captured, okay, there's obviously no correlation whatsoever. So the answer to question 2 would be the habitat floral host does have no relation to the concentration of the imidacloprid given to the bees and the date the bee was captured.